I'm going to start off describing why anyone would want to find an iterated integral.
What are you doing? What do you think?
Well, that's right. We're going to use this for something, and one thing we can use this for is to find the area of a plane region. If we consider the plane region where x goes from A to B, and y is between g1 of x and g2 of x, as this picture shows here, then the area between the graphs and between those limits can be calculated with calculus 1 techniques like we did in Calc 1, right? Just like this, that's been done, we've already done that. But let me show you. If you use an integrand of 1, this is the same thing as this, because integrate this with respect to y, you get x, right? And then you put in the limits, that would be g2 of x minus, I'm sorry, it would be y, and put in the limits y equals g2 of x minus g1 of x. So that's exactly what you have here. So if we replace the integrand with the integral listed above, we'll get a double integral to represent the area between the curves. Notice our integrand is just 1. And you can think of it for now as, imagine that over this region we have height 1, right? And so think of the volume of that, if we had height 1, would just be the area of the region. And that's precisely what this is. And so this double integral, or this iterated integral, will indeed give us the area between limits a and b and between functions g1 of x and g2 of x. So, but for what it's worth, in a similar fashion, if it's more convenient, like if we have functions on the left and right and constant limits as upper and lower, then we could do integrating with respect to x first. H1 of y would be the lower limit, and h2 of y, the one that's up here. Like here's the bottom, here's the top, and here's y goes from c to d. This is x goes from h1 of y to h2 of y, and notice that since dx appears first in the iterated integral, then we need to integrate with respect to x first. And that's how that works. So the whole thing can be summarized with this, okay? The area of a plane region, if r is defined as above, and in other words, x is a number between a and b, including a and b, and y is bounded by function g1x and at the bottom and g2x at the top. For those functions continuous, then the area of the region R is given by this iterated integral. And of course I wrote it with the dy first, but we could get the same result from this if the function was more conveniently written like that. So, and that's, I guess that's what part 2 says here. So now that we know how that works, I guess I could be fancy here and make my backgrounds the same. Pardon me just one second. I like it if it looks nicer like this on my video, although my PDF files might not have this sweetened up like this, but there, it looks nicer to me somehow, even if it does use a little more printer ink if you run it off. Okay, so we've got this formula and this formula that will give us the area of a planar region.